Hello, Assalamu alaikum. Good morning, everyone. Welcome to the class. Yeah, okay, thank you. Yeah, let us start the class. So again, I'm repeating the same announcement that you have an Major 2 exam on Thursday. I mean, day after tomorrow. Okay, so um, so when you upload your solution on the Blackboard, also copy the top page with your name and ID. That actually keep the things more organized. So don't forget it. And yeah, this is the thing I want to ask all of you. Okay, so it's about 8255 IC interfacing, input output interfacing. We already, it is, a very basic things are part of the Major 2 syllabus. And we already started it in the lab, and also last class we discussed that 8255, it actually helps to interface the input output system to the microprocessor. So there are three modes. So we are concentrated on the mode 0. Mode 0 is basic input output mode. So mode 1 and mode 2, bit complex, not too much, but I think probably we will not get time to touch them. Okay, and control word, control word, it's 8-bit control word, and which bit represent what? It is already, we discussed that this LSB bit, it actually represent port C lower, then next one is port B, next one is for mode, and next one is port C upper, then port A, and then next two bit is for mode, and then next one, D7 is 1. This is already we discussed many times. And also last class we discussed that how to find the address. It depends on three signal. One is chip select signal. Okay, so the chip select signal, it must be low. If wherever the signal is coming from, but as it is a bubble, it has a bubble, or if there is no bubble but with a bar, that means it is a active low signal. It is active when it gets a low signal here. It is the idea of it. 200, digital IC, and other two signal, A0 and A1. How they are connected? They may be connected. A0 may be connected with A0 of 825 microprocessor address line. A1 may be connected with A1, or maybe A0 connected with A1 and A1 connected with A2, or maybe different way, right? So it depends. So they are the variables. So chip select signal is fixed. A0 and A1, the signal A0 and A1, they are the variable. So it depends, and we discuss in the class that how actually they actually represent, actually they are responsible to determine the addresses. Here actually, okay, and this one is also we discuss how to find the address. But now let us discuss something more. So for example, here we already last class we said what are the addresses, so let me repeat it again. So address, we say that address signal, the A0 and A1 and chip select, these three signal are responsible to determine the address. Now let us find the addresses of ports. So start writing A15, A14, A13, and A12. Okay. Then A11, A10, A9, A8, A7, A6, A5, A4, then A3, A2, A1, A0. Okay. Now look at here. So the A15 is not used here. So A15, 14, 13, 12. So this 4-bit is not used here. You can directly write don't care cases. Don't care. And then A11 is also not used here. So A11 we can put it don't care. So then A10. Look at here, A10 in use. So it is the input of the NAND gate. So NAND gate, you know, when actually you get a zero signal on the output of the NAND gate. If all the inputs are 1, then actually this is the only condition that if all the inputs are 1, then output will be 0. So A10 is one of the input. So definitely it must be 1, right? It must be 1. And then A9 also is one of the input of the NAND gate. It must be 1. And then A8 also 1. Okay, and A7 is not used here, so A7 is don't care. And A6 is used here. It is must be 1. And 5, 4, no use. No use of 5, 4. And then A3 also not used. And A2 and A1, you can see A2 is connected to A1 and A1 is connected to A0. So that means A2 and A1, they are the variables, and A0, there is no use of A0. So we can see A0 is also don't care. Then what are the variables now? A2 and A1, they are the variables. These two are the variables. So they can be 0, 0 for port A. They can be 0, 1 for port B. They can be 1, 0 for port C. They can be 1, 1 for control register. Okay. So now what is the port A address? What is the port A address? What is the port A address? So port A address is, if don't care cases are 0, so 0 and then 7 and then 4, 0, 7, 4, 0. 0, 7, 4, 0. H. So this is for port A. Port A. Okay, and then next one is next one will be 0, 7, 4, 2. 0, 7, 4, 2. And definitely it is hexadecimal number. Okay, it's not a decimal number or binary number. So this is for port B. Okay, and same way you can write also same way. I mean for port C, 0, 7, 4, 4, 4H. This is for port C. Port C. And then next one is for control register. 0, 7, 4, 6. Okay, is it clear? Is it okay? Control register. Okay, so it's is already we discussed, but just for repeating. Okay, so this is the way actually we can find the addresses. Once addresses are done, so now we will find the control word. What is the control word here? So control word. So let us find the control word. So this is the control word. Okay, so this is for port C lower. So port C lower. So look at here. First of all, okay, let us discuss the problem here. So here actually port A is connected to 8 LEDs and port B is connected to 8 input switches. Okay, they are the switches actually. They can be 1 or 0. And port C lower, PC not to PC3, port C lower is connected to a 7-segment display. You know the 7-segment display, right? We can display BCD number 0 to 9. Okay, 7-segment display. This is already you know it. So like you know these display is very commonly used in most of the digital display, like in your watch or in the I mean any kind of mostly this display is commonly we can see 7-segment display. So it's like a 7-segment display. You already know it, right? 0 to 9 we can display here 0 to 9. This is a 7-segment display. So in input switches, it is similar like the lab one, like the switches that is connected to port B. So it actually it actually used to for input devices. Switches are input devices. So what are the switch pattern is there? So according to the switch pattern, like for example 1 0 0 0 1 0 something like that. If it is the switch input switch pattern, LEDs are on accordingly, for example. Same like the experiment number 4. So for example, LEDs are on in the same way. And what about this display that is connected to the port C lower? The display actually, the purpose of display is actually to show the number. How many switches are on? How many 1 are there? Is it a 7 1 are there? Is it a 6 1 are there? For example, the input switch condition is 1 0 0 1 1 1 0 0. For example, the switch condition, yeah, you put the switch. So how many 1 here? 1 2 3 4 4 1. So the display will show 4. So actually that means in our program we have to find the number of 1. How many number of 1 are there? So this kind of problem we already did it in previously, like how many ones in a 16-bit number. So the same way actually, so it's very simple. Rotation, you have to make the rotation either left or right, doesn't matter, and we will check the carry flag. If the carry flag is 1, that means there is 1 1, and then we will make it 8 times. Okay, 8 times, and every time we will check it, is the carry flag is 1 or not. Idea is okay. This one is this is the idea, right? Is it okay? Anybody has a question here? What is the how actually we can determine the number of 1? Okay, so now if it is done, then find the control word. So what is the control word actually? So this one is for I mean yeah, D naught. It is for port C lower, PC lower. Again I am writing PC lower. This is next one is for port B. So we are writing it again and again so that actually it easily set up in our mind. Okay, so and next one is mod. Okay, and next one is for PC upper. Okay, PC upper. Okay, and next one is for port B. Sorry, port A. And next two bit is for mod. And this is by default 1 to make it active. Okay, and port C lower, look at here, port C lower is used as an output port. Okay, so this is output, and port B is used for input switches. Okay, and mode is simple input output mode, so mode 0. And port C upper, there is no use, so it is don't care. Okay, and now port A, look at here, port A used as an output port because its LEDs are connected there. And it is, this 2 bit is for mod, so it is 0 0. So what is the control word now? If don't care cases are 0, then it becomes 8 2, right? So control word is either 8 2 H, or if don't care cases are 1, then it becomes 8 1 0 1 0, so 8A. Okay, 8A, 8AH. Is that clear? Control word is okay. Okay, so now it's about writing the program. It's writing the program. Okay, I am deleting this the writing. Is that okay? So you need anything, or it is clear? All the, I mean, all the extra writing that I wrote here. If I press the clear button, everything will go. So is it okay, right? Yes. Okay. So clear now. So it's now about writing the program. So then dot model is small and dot code. These are the things, common thing, right? So it's not written here. Maybe you can write dot model. So this two line actually doesn't matter. Dot model, dot model, dot model is small, and then next line is dot code. Dot. So this two line is missing here, so it's okay. And so then we start move al comma control word. Control word is 8.2 or 8a, so anyone. And then out control, I mean control register address. You know the control register address 0746 it is already we determined. Okay, control register address comma al, that means control word is sent to the control register. And then now we read the input switches. Input switches are connected to the port B. And what is the port B address? 0742. So move al comma 0742h and send it to the port A, because it's the same pattern. If it is in the same pattern, we can just directly send the al to the port A. Out port A address comma al. But if it needs opposite pattern, like for example, it is if it is like 0 1 0 0 input switch pattern, 1 1 0 1, and LEDs are opposite pattern. That means this 0 means LED is 1, and here it is LED is off. Here it is LED on 0 off on 0. If something is like the opposite pattern, then we must make a NOT gate. We must make a not gate here, not AL. Okay, this is we already discussed in the lab, right? we can write the not AL and then out port A address comma L. Is it clear, right? If it is the opposite pattern, then just make a NOT gate. I mean, make a NOT operation, not AL. Okay, and then out 0740H comma AL, so that means port C accordingly. And then now it's about finding the number. How many one are in the input switch condition? How many one are there? So first of all, move, for example, one, a number of one is 0. Move BL comma 0, and move CX comma 8. It is 8 is counter because we have to make 8-bit rotation. Rotation left or rotation right, both are okay. Rotation left AL comma 1. Okay, and then jump not carry. If it is not no carry, come here. If it is no carry, come here. If it is carry, then increment BL because we get one. We get one. Is there. So the increment BL was 0. Now it becomes 1. If it is not, then what is happening in there? Just loop. You can directly write the loop actually. Directly write the loop. So instead of these two, we can directly write loop L2. Loop L2. L2. Yes, so decrement CX and jump not 0 L2. Same thing is. And then so that means 8 times it will continue, and it will if there is 1, it will increment. So BL has the number of 1. Now send BL to AL. This number we can send it to AL because before we send it to the port C. So out port C address comma AL. So that means the number that so binary number for 3 is, for example, number of 1 is 3. So 0011. If we send this 4-bit number 0011 to port C, then it will display the 3. So this is the way actually. So but why actually we send the number in BL to AL? Because through AL we have to, through the accumulator we have to done it. All the ports, all the port input output system, it must be done through the accumulator AL. And then jump start again, continue the process again and again like that. Is it okay? So yeah, this is about the about this. Okay, so let us go for another. Okay, so now look at here. It is, for example, a 7-segment display. So 7-segment display, that 7-segment display, it has a 7-segment display. Just I said that. So what is 7-segment display? But sometimes like it is a set of display. I mean a set of 7-segment display. Like for example here 8, a set of 8. So that means at it. I mean we can display 8 character here. Like for example, you want to display UOHB, University of Hafra Al-Baten 2019, for example, just for example. So that means U will be displayed here, O will be displayed here, H will be displayed here, B will be displayed here, and 2 will be displayed here, 0 here, and 1 here, and 9 here. Okay, so this is the, so that means sometimes like for example we have a 8 character. I mean 8 character, it may be alphabetic or alphabet character or numeric character. Okay, so that so we can display them here. This kind of things we can see around us. Okay, so what actually we do, it has a 7-segment display driver. It is connected with the, for example, port A. So that means port A is connected to the driver of the 7-segment display, and output of the driver is ABCD. This is, you already know it, ABCD, EFG, because 7-segment display, this one is A, this one is B, this one is C, this one is D, E, F, G. So 7-segment here, and there is also extra thing is dot. Sometimes we may need the dot point, DP. So there is also DP. If we do not, we can keep it off. So DP. So eight inputs A, B, C, D, E, F, G, and DP. These 8 inputs are necessary for displaying a certain character. Okay, either alphabetic character or numeric character. Okay. Now look at here. So this 8 line is for all the 7-segment display. So that means if we cannot send, like for example, we cannot send them together. So what is the A, B, C, D, E, F, G, and DP for U is not same as what is for O and what is for H. They are different. Okay, A, B, C, D, E, F, G, H, E, F, G, and DP dot point. So these are not the same for all. So how actually the things we can organize it? We use another input device, another port. We use another port B, for example. So port B, you can see port PB0 is connected to this bit. 1 is connected to this bit. So this is digit driver. The digit driver actually it makes 1 on, then next one on, then next one on, and we can send the corresponding data there. Then next one on, but it is a very short period of time that we cannot, human eyes cannot see the difference. Okay, so that means we'll see in the display UOHP 2019, but they are not exactly the same time. It's very short time difference, like 1 millisecond or 10 millisecond. Okay, it depends on the hardware device. So there is a gap. So this gap actually very short time that human eyes cannot see it. So we are seeing that it is UOHP at a time, but actually it is not at a time. For example, U come first, then O come first, then H come first, H come next, and then B next, then 2. But gap is very short, and then again the processing, these things are going again and again. So that means each digit is on for once. I mean at a time one digit is on, then next one, then next one. It's like that. So you get the idea. The idea is clear. So that means you can see it is written here, sequentially turn on 1 digit at a time. 1 digit is at a time. It's sequentially. Like for example, this one is on first. Okay, for example, this one is on. U for U. Then we'll send data to the U for U. Then next, so that means PB7 is 1. Others are 0. So that means this digit is on. This is active. If this digit is active, now we'll send the data through port A for U. For U, what will be the A, B, C, D, E, F, G, and DP, and then we make all the digits 0, just except PB6 is 1. Okay, so this one not at a time 2 on. So next digit is 1 on. Now we'll send what is the ABCD data for O. So what is the gap time? Gap recommended time between the digit gap is like 100 to 1500 times per second. Oh no, this is the rate that each second we can get 100 to 1500 times. I mean 100 times to 1500 times we can do it. Anyway, so it's like, for example, the gap between each digit is 1 millisecond, for example. Okay, 1 millisecond. So yeah, this is the idea. Okay, let us have a look. And also another thing is, we already know it, this display, this 7-segment display, they may be common cathode type or common anode type. You know what is called common cathode, common anode type? Common anode is all the, so LEDs, you know, LED has anode and cathode. So all the anodes are together. It's common. So it is connected to the VCC. And if that means if you send 0 here to A, then that means this LED is on. If you send 0 here, then LED B is on, C on. That means to turn on any LED, we have to send 0 for common anode system. And what is for common cathode system? It is this opposite thing. So all the cathode of the diodes, LED diode, light emitting diodes, they are connected to the ground. Okay, and if we send 1 here, 1 means 5 volt. If we send a 1 here, so that means this A LEDs is on. If we send 1 here, the B LED is on, C LED, so on. So that means 1 is necessary to turn on any LED. It is for common cathode system. So LED, so that means anode and cathode system, there are two types of 7-segment display. All right, is it okay? You understand it, right? It's a basic idea actually. This is already, you know it from the 200. Okay. Yeah. So now, for example, we have a 7-segment display here. So it's A, B, C, D data is coming from here. If we want to display E, if you want to display E, like look at here, what is E? That means we have to turn on this A LED. This A segment should be on. Then B is off, C is off, D should be on, E should be on, F should be on, and G should be on. Dot point off. So then this character E, we can see the E. So okay, so look at here, if their order is like that, D, P, G, A, B, C, D, E, F, G, and dot point. It is in this order. So that means we must, what we have seen that A should be on, B should be off. This is for the common cathode system, common cathode system. B should be off, C should be off, D should be on, E should be on, F should be on, and G should be on, and dot point should be off. Okay, and then what is the hexadecimal number? It is 7 and it is 9, 79H. And for O, look at here, for O, except G and DP, all the segments should be on. So A, B, C, D until F, Z, and dot point. So it becomes like 3, and then 1, 1, 1, 1 is F, 3FH. A very basic idea. And then, for example, we want a slash, we want a hyphen here. Use dot point, you know, like, so sometimes we have to use like 2.5. Okay, so 2.5. So this point, actually, how can we show it here? This is for point. Okay. Okay. So for example, we need a hyphen here, just like that. So hyphen is like G is only Z is on. Okay, so G is on. Others, all the bits are 0. All the bits are 0. So it becomes 0, 1, 0, 0 is 4, and this is all 0, 4 zeros. So it is just for example. So in a common cathode system, for common cathode system, so that means this display is common cathode, CC. You can see it is, for example, CC. Or you can see this common point is like, you can see this common point is ground. If it is like that, so that means it is common cathode system. We must send 1 to turn on the LED. So this is also the same idea. I mean, we can understand that it is a common cathode system. Or maybe it is defined, it is written that it is CC, common cathode system, or the common point is connected to the ground. Okay, so is the idea is okay? Is it clear? Okay, so let us go for the for displaying something here. Okay, so it is the same thing. So it is about showing the hardware connection. Don't worry about it. Don't worry about it. It's the same thing. So like I mean, we can use the transistor or something else. It's about okay. Okay, so for example, we want to display ALP for Assembly Language Program to display UOHB 2017. Okay, for example, this eight character we want to show it on the display. So port A, port B, port C address. For example, the addresses are given 00, 01, 02, and 03H. It is, for example, given. And control word is, control word is, it is, you can see here that control word, not this one, this first one. You can see port A and port B are used, and both are input port, sorry, output port. What will be the control word here? Let us find the control word here. Okay, so this is the 8-bit. So this bit is for port C lower. So port C is unused, don't care. And then this bit is for port B, and it is an output port, right? Output port, because we will send 1 or 0 through to the port B. And this one is for mod 0. And then next one is port C upper, it is don't care. Then next one is for port A, it is also output port. And next to 2-bit is for mod 00, and it is 1, default 1. So it becomes 80 if don't care 80 or 189. Is it clear? So either 80H or 89H. Is it okay? Control word is okay? Control word is okay? Yeah, so 80 or 89 is. So now let us write the program. Yeah, so control word is 80H. Okay, so this is actually with a semicolon, it is given. That means it is a comment. So for your information, okay, so this is a comment. Okay, now dot model is small dot code, then start move al comma control word, and then out control word address. What is the address of the control register 03H? 03 is comma al, and then move bl comma a. Why actually we use it? I tell you, because like we have to, if you can see here, we have to yes, turn on the LEDs at a time, only one LED or should be on. And for example, first one is on first. This one. So this one is connected to port P7. So that means all the bits should be 0, 0, 0, 0, 0, 1. Actually, it can be different way. For example, port 0 actually makes the things on. Okay, let me erase it actually. So actually, it depends on the transistor actually. Is it a PNP transistor or NPN transistor? So for example, here actually the idea is if we send 0 here, okay, I'm just if we send a 0 here, then that means this is on, others are off. 1, 1, 1, 1, 1, 1. So that means this is 0. So that means this one is on active first. Now we will send the data A B C D E F G for U. Okay, and then what actually we will do? So we will make a rotation. So it is like that: 0, 1, 1, 1, and then 1, 1, 1, 1. So for example, we keep it in BL, and then we make a rotation, one bit left right rotation. That means this 0 will come here. and then it will be 1 1. Okay, it will be like that. So it will be like that. Then we'll make another rotation. So how many times we will do? 8 times to complete whole process, and then we do it again and again. Is it okay? Do you understand this one? Is that clear? Yeah, so it depends on actually, so 0 or 1, it depends on the transistor actually, PNP transistor. If you look at here, for example, look at here, if we send a 0, if we send a 0 here, okay, I think it's not necessary. So this is about the circuit. Okay, so now look at here, we send, okay, so this data is for, here is a table. Let us write the table at the end. Table E. So for U, the table is 3EH. You can put the put on the in yeah. If you put it, I mean, if you determine it like that way, okay. So for U, what will be the data for U? For O, what will be the data? It is already 3FH. And for H, what will be the data? So on. So for example, they are like that. So this is the data. We put it for in the table for UOHB2017. All right, and then move SI comma offset table. That means first address of the data is now in SI, and move AL comma 01111. All the bits are 1, just only bit 7 is 0. Then we send it to the port B, because port B address is 01. We send it to the port B. That means what happened now? What happened now? If you look at it in the, so port, this one is 0, all the things are 1. That means this one is active. Now we'll send the data through the port A, the data for U. So then out. Okay, so this AL data we have to shift it to the AH, because we will use AL again. So move AL comma square bracket SI. What is SI? SI actually holding the offset address of the first data. So that means for U, so 3E is now in AL. Out 0 port A address comma A. So that means U is displayed there. Then we for example 100 millisecond delay between each character. So called delay. Delay is the delay, 100 millisecond delay subprogram, we already know it. Okay, so 27,300 for 5 megahertz machine, like that one that actually we use in the lab. Okay, for 100 millisecond, this is the delay. And then yeah, if it is not mentioned, you can use this one. And if it is mentioned that it is 8 megahertz microprocessor or it is 10 megahertz microprocessor, what should be the n? What is the value of n for the 100 millisecond? You have to find it. Okay, okay. Then increment SI. SI is for the next data, and rotation right AH comma 1, because this one is now in AH. So we will do 1 bit right rotation. That means this 6 number bit will be 0, all are 1. And then we send it to the AL again, and decrement BL, because we have BL 8. Now decrement BL, jump not 0, it will come here, again repeat, and it will do the process again. And if it is 0, then jump stop. So that means all the process done. So this is the way actually it works. We will take it. So if it is, I mean, if it is not 8, I mean, BL is not 0, that means comes a repeat here. We will do the, we will take the data again and again. This is the way actually we can do it. Is it okay? So I mean, I think here is a one. So jump, if BL is not 0, BL is not 0. AH in AL. I think one line is missing. Or jump not zero, repeat. So repeat, actually I think repeat should be here. This repeat, it should be here, not this line actually, because we do the one bit right rotation here, and then we have to send it, because we do not send it here. Before, so before here, repeat should be here, out here, out 01H comma L. Yeah, so repeat should be here. This repeat, it should be here. So this is the way actually we can work on it. So yeah, this is the idea. So okay, is it okay? Do you understand this one? Yeah. So so this one actually we can use, like we can display a set of character, like 8 character in a set of display. If we have a set of display, we can say we can display a set of character there. It's like that way. So this is for the displaying character, and I think we do not have time to discuss about the stepper motor, how we can control the stepper motor. So DC motor, actually the idea is clear, because yesterday I discussed in the lab time. So DC motor, how we can, using the switch, we can control the operation of the DC motor. Like we can make it off, we can make it clockwise rotation, anti-clockwise rotation, so on. Okay, so today's class is not part of the Measure 2 syllabus. So Measure 2 actually up until the yesterday, I mean last class. So do you have any question? Okay, then. So all right. So